Welcome to VAK's lecture. In our previous videos, we have seen about process and process control block. If you have not seen, you can catch here. Links are in description box. Today in this video, we will see about process states. The process right from when it is created until it goes terminated, after execution, it goes through various states. We are going to study these states and how and why the process transits from one state to another. There are primarily five states in process life cycle, which are as follows: new state, next is ready, then comes running, and then next one is wait or block, and the next one is or the last one is terminated. And this is how the transition happens between the states. This complete diagram is called process state transition diagram, or we can also call it as process life cycle. Let us understand each and every state one by one. First state is new. When a new process is just created, it is present in this state. For example, when you write some program and save it, it is stored in hard disk, that is secondary memory. When we execute that program, operating system just pick it up from the secondary memory to place it in main memory. At that time, when it is just picked up to get placed in main memory, we can say that process is created and that state is the new state. Another example can be when you just open any application, let us say Google Chrome, the process is just created at that time. That is when it is in the new state. When process gets to new state, then the process structure is created and process control block is created. When these are created, it becomes complete or ready. Then it transits to the ready state. We can say the process is in ready state. When it enters the main memory or RAM and is ready for execution, then this state is ready state. Process waits in ready state until CPU is assigned to it for execution. Many processors can be present in ready state or ready queue waiting for their execution. Now, after waiting for some time in ready queue, the process will be scheduled for execution. The CPU will start executing the process. When the CPU starts executing the process, at that time, process transits to running state, where the CPU executes the process. CPU will execute line by line the executable code. Now, again, it can go back to ready state from the running state. But how? Let us see. Let us say our process is getting executed by the CPU and a high priority process comes in main memory or ready queue. As we have seen, CPU will give importance to high priority process, so it will stop executing our process and start the execution of high priority process. Our process will get preempted. That means it will be force stopped and it will go back to the ready state. Or as we have seen in time sharing operating system, a process is executed for some quantum time. Then the next process is executed. In that case also, process can go to ready state from running state and wait in ready state for its execution. Another thing is, while process is in running state, it can require some input-output operation or some other event. CPU cannot wait till that time, so CPU stops the execution and process goes in waiting or blocked state, where it will complete the input-output operation or other required event. Here also there is waiting queue where the multiple processors are present. Processors that are in waiting queue are present in main memory only. After completing the required operation, it cannot directly go to the running state. It has to go to the ready state, where again it will get scheduled for execution. Another thing that can happen in running state is CPU will completely execute the process. It will execute the complete executable code. Process will get out of the main memory. Then the process will get completed and transferred to the termination state. In termination state, the process structure will get deleted as well as the process control block will get deleted and process will get terminated by the operating system. These are the primary process states. There are some additional states also. One state is suspend wait and other state is suspend ready. Let us understand with an example. Let us say many processors need IO operation. So CPU sends them to wait and block state. They are stored in waiting queue, which is present in RAM. We know that RAM or main memory is limited. So in worst case, the wait queue will get full. Now, where to keep the processors that will come to wait state? To tackle this situation, processors are transferred to suspend wait state. The suspend wait is in secondary memory. So, these processors are transferred to secondary memory so that we can make the space in wait state or wait queue. Once IO operation is done, it can get back to wait state and then back to ready state. From here, it can again get scheduled. Now, let us see suspend ready. Similar to previous situation, if ready queue is completely filled with processors and high priority process arrives, as it has high priority, it must be added to ready queue. So, in such case, other low priority processors are transferred to suspend ready. Suspend ready is also present in secondary memory like suspend wait. When suspend wait has enough space, processors present in suspend ready are transferred back to ready queue. One more situation that can occur with process in suspend wait is, let us say a process in suspend wait has completed IO operation and it needs to get back to ready state. But wait state or wait queue is still full and there is no place for any process. Then how it will get back to ready state? In this situation, the process can directly go to suspend ready and from there it can go to ready state. This is overall structure or overall complete view of a process state transition diagram. So we are done with process states and process state diagram. Hope you all understood the concept. If you find the video helpful, please like the video, share it and subscribe my channel. Also hit the bell icon for more new updates. Thank you.